Welcome to Algebra 2. Our notorious unit has begun, logarithms, Unit 8. Today's date is January 12th, 2021. Yeah, objective today is to, what?
Evaluate logarithms with various bases, including fractions.
Ooh, and fractions by themselves are scary, and then I'm combining something scary with something new scary, old scary, new scary. All right, let me talk about the what power function. Oh yeah, Andres.
Wait, is that supposed to be fractions?
Does it say factions?
Yeah.
It's actually about
Yes,
to
it is supposed to be fractions. Go ahead and log extra credit if you have the tracker. I don't think I've distributed
ask
that
what
yet
a
this year, though.
faction was. I was like, am I
With
supposed to know?
factions. That's interesting because the standard last year is different than this year. I must have changed that, but I have a typo. Okay, so what power function? It's a brand new function that I'm teaching you, semi-related to logarithms. Don't think of this hard word logarithm. Think of the what power function. So I'm going to read this statement right here. It's not what power to 8. It's 2 to what power is 8. That's how I read this thing. 2 to what power will give me 8. That's what this function is. I've said it over and over again. And you guys should be able to tell me, what power should 2 go to in order to get to 8? 2 to what power is 8? And you will tell me, you can hold it up on your fingers. It's an integer. It's either 1, 2, 3, 4, 5. Just use one hand. 2 to what power is 8? I've only got, it's not 0, 5, or 50, Andres. It is 3. Yes, thank you. 2 to the third power is 8. So what power does 2 need to go to 8? The answer is 3. That's the what power function. And I'm going to abbreviate it WP because right now what power is laborious. I do not like it. All right, let me try asking you the same question. First of all, who can read this the correct way? Yeah, Charles, read this correctly.
Is it what power? 3 to what power is 27?
There it is. All right. And then integer answer again, one hand. Everyone hold up your hand. Maybe a fist if you don't know. Everyone hold up your hand though. What power, I'm restating Charles's question, what power does 3 need to be raised to in order to get to 27? And the answer is 3 again. Yes, so we've solved this what power function. It's 3. Good job. 3 to the power of 3 is 27. If you don't believe me, hopefully you've already memorized this from a previous unit, but 3 to the power of 3 is, not road danger, 27. Oh, let's try an even harder one. Are you guys ready for this? Again, a different person to read it. I just want you to read it. This one. Yeah, Jade.
10 to what power is 10,000?
There it is. Okay, this might require a little bit more thinking. And let me give you some hints. You should be able to do this with one hand still. The power of logarithms is usually, or the what power functions, we're not in logarithms. The power of what power functions is they can be answered on one hand most of the time. Most people are already giving me the correct answer, which is awesome, but let me give you this hint if you're not quite there. 10 to the power of 2 has 2 zeros. 10 to the power of 3 has 3 zeros. This has 1, 2, 3, 4 zeros. I don't know if that gives you a hint enough. So what power does 10 need to be raised to in order to get to 10,000? You guys should all be answering. Not 10, Andres, but good job. It is 4. Good job. All right. So you have these what power functions down for the basics at least. Okay. And then let's review these rules of exponents. They come back and haunt us. They're not just learned in Algebra 1, not just learned in Algebra 2. They come back in pre-calculus as well. Pre-calculus should really be called Algebra 3 if you're asking me, but whatever. X to the power of 0, anything to the power of 0 for that moment is, and you guys can do this with your cameras again, it is 1. There it is. Good job. It's not 0. If you held up 0, you're doing it wrong. Power of 0 is 1. All right. This one you can't do with your hands. You have to actually raise a quiet hand to answer. X to the power of negative a. How do I rewrite this without any negative power as a review? Got some hands. Yeah, Jose?
Is it like the fraction form, right?
Yeah, it is. Yeah, what is that fraction?
So it'd be 1 over x to the power a? Or
Yep.
would it just be negative a?
No,
in the
you
fraction?
got it right. It's 1 over x to the power of a. So
Okay.
you flip it and then you make it a positive power, 1 over x to the a. Perfect. And then kind of the reverse of Jose's rule. How do I do this one? One that's already a fraction, 1 over x to the power of negative a. I want to get rid of that negative power. What would I do? And Fern, by the way, I got your message. I just never said anything. So thank you for letting me know. Yeah, what is this going to turn into?
Would that just be x to the power of a?
It is indeed x to the power of a. You flip it back to the normal, just numerator, and then make it a positive power. You have to have these down today pretty well. You have to be at 4 or 5 fist of 5 on all 3 of these rules. Otherwise, you're going to struggle today. If you're only at a 3 or 2, it's going to take you a little bit more time to do these what power functions. Just out of curiosity, with these 3 rules, where are you on your fist of 5? I told you you should be about a 4 or 5. Uh-oh, Andres, is it really a 2? A 3? Okay. It's better, but you'll still go a little bit slower. That's fine. Math is not about speed. See, Fern's at a 4. Most people are giving me some high numbers, which is good. That will make your life easier. I've taught you. I've done my job. All right. Let's do example 3. Again, new reader. How do I read this problem? It's not WP5 of 1. How do I pronounce this function? Yeah, Gunnar.
WP5 of none.
Come on, Gunnar. I see Jenny gave me the 4.
I don't want to say it.
5. You start with a 5. You start with this thing. Come on, Gunnar.
5 to the power of none.
What?
Oh wait, no. I 5 to the power of WP.
5 to what power gives us 1?
Oh, okay.
Yeah, so say it once
I just
again.
wanted to participate, so I get randomly called on.
Okay, well, I'll come back to you then. Say it
Whoa,
correctly. Now.
whoa, 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 whoa.
Say it correctly.
Whoa.
Come on, Gunnar. Let's get through this lesson. Let's give people a chance to do homework.
5 to the power of WP equals 1.
5 to what power gives you 1?
5 to what power is equal to 1?
There it is. Okay. And what is that answer? Again, these are powerful. You can do them on your fingers for now. Eventually, they're going to be a little bit harder. Everyone is giving me 0. Good, because 5 to the power of 0 is 1. That's literally this rule. Anything to the power of 0 is 1. So the answer to this what power function is 0. You've getting the hang of this what power function? Getting okay? Okay, let's go a step beyond. Let's see how hard I can combine these rules. The what power function for this one. Okay, so another person to read this one. If you haven't read anything yet, you are going to be responsible. Yes, Jenny.
7 to what power equals 1/7?
There it is. All right, and this one you can do on your fingers, and you have to be a little bit tricky about how you do it. See, Charles already figured it out. What's the answer for this one? On your fingers. Use one hand for either positive or maybe that's positive and that's negative. I don't know. See, 2 people have an answer. 3 people have an answer. 4 people have an answer. You can do it in the chat too. Most people are getting this. It is -1 because if I take 7 to the power of -1, it flips it, makes it a fraction, and it's now 1 over 7 to the positive 1, and 1 over 7 to the positive 1 is 1 over 7. All right, so that's getting a little bit more tricky. I'm gonna get pretty tricky by the end of this lesson, so just a heads up. By the way, by this, I haven't taught you, and I'll talk about this later. Okay, so logarithms. Let's actually talk about logarithms instead of the what power function. So the proper name for the what power function, as you might have guessed, is called a logarithm. You've been learning logarithms the whole time. I reveal behind the curtain. It is logarithms. I'm introducing that scary name again. So really, instead of saying 2 to what power is 16, the correct way of writing this, and it's not that different, log base 2 of 16. It's still asking the same question. And whenever I read log base 2 of 16, I know most mathematicians and YouTubers read this way. I'll get your question in a second, Wyatt. Most people everywhere in textbooks and stuff, they say log base 2 of 16 is what? I don't think like that. I think 2 to what power gives me 16. I always revert back to the what power function, and I want you to do it as well. And you can answer this as well. 2 to what power is 16? And again, you should be able to do this on one hand. 2 to what power is 16? 2 to the power of 3 is 8. One more. 4 gives you 16. Good job. Yeah, 4. I'll teach you the official way so you don't sound silly when you go to college. This is technically pronounced log base 2 of 16. So you should be able to read it correctly in class. But if you ever revert back to say 2 to what power is 16, yes, that is perfect. That's how you should be interpreting it in your head. The correct way when you want to not be made fun of when you leave high school, log base 2 of 16. All right, we know both ways. Let's try these. So legit logarithm problems now. Log base 3 of 9. Hopefully you're translating that in your head to the what power function. You can do this with your fingers. And these next, the ones like example 6 and 7, we're going to have to be a little bit tricky. Yes, you guys got it. 2. 3 to the power of 2 gives you 9. All right, so the answer to log base 3 of 9 is 2. You guys are already way above where Mr. Sindel was. I did not know how to do this thing when I was in high school. It took me until college to figure that out. Good job. You're smarter than Mr. Sindel. Jade's already answered example number 6 correctly. Log base 3 of 1/9. Convert this to a what power function. It is tricky because you have to use rules of exponents. Maybe I'll zoom out so you can relook at those again. These are the only rules of exponents that I'm using for, I think, this entire unit, as far as I remember. Oh, wait, they do come back for a proof of log properties, but basically when you're doing logarithm evaluations like today's homework, these are the only rules that you need. All right, so log base 3 of 1/9. So Jade already has it, Charles has it, Wyatt has it, Jose has it. So the correct answer is -2, but let me show you how to think about this problem. So the correct answer here is -2. But why? So there's 2 pieces to this. First, we'll make sure that you're step 0. Think that it is a what power function. What power does 3 need to be raised to get to 1/9? That's always a step. That's step 0. But the 2 steps that I was talking about is first, I see that this is a fraction, and I started out not with a fraction. In order to get from a non-fraction to a fraction, I need a negative power. That's where this negative comes from. The next step, well, how do I get from 3 to 9? Well, that's the power of 2. So negative and 2. Those are the 2 steps that I'm seeing here. Okay, I know that these are getting tricky. And I see Andres said it in the chat too. I missed that, sorry. Okay, here's an example number 7. We're getting even harder. I'm throwing more tricks at you. How much can you handle? I'm now saying log base 1/3 of 27. First, convert it to a what power function. Again, you can still answer this on your fingers. Once we get to example 8 and 9, we can't do this with fingers anymore. They get too hard. Most people are getting it that I see in the camera. Everyone that has answered has it correct so far. Jose has it, Jade has it, Charles has it, Wyatt now has it. It's interesting to see who has their camera reversed and who not. Andres has it. I see your chat. Thank you, Andres. Cohen has it. You guys are getting this. It is -3. Again, there are 2 parts of this. Step 0, it's a what power function. What power does 1/3 need to be raised to get to 27? Okay, so I understand the question. Notice that I have a fraction and I need to turn this into a not fraction. I'm invoking this 3rd rule that I've talked about here. I have a fraction. I want to get it to a non-fraction. I need a negative power somehow. So the answer is going to be negative. If you need to convert between fraction and non-fraction, it should be a negative. Okay, well then the next question, how do I get from 3 to 27? And you've already answered that question before. You said up here in example number 1, 3 to the power of 3 gives you 27. This is just a little bit different. It's a -3 now. So already we're doing pretty difficult questions. And what are we, like 12 minutes into this video? Less than that. You guys are doing awesome. Okay, this is a good checkpoint. How well are you doing fist of 5? How well are you understanding these problems? I'm seeing 4s and 5s from the people that have been answering. I'm worried about the people that have their cameras off and haven't been messaging me in chat. All right, Andres is at a very specific 3.421 with a direct message. I'm seeing mostly 4s though. I'm concerned about Fern and Jessica who haven't responded to anything yet. What are you guys at? 4, fist of 5? Are you at 3, 2, Fern, Jessica? Are they there? I don't know. They're not responding. Let's move on.
I think Fern said 3.
Okay. Oh,
It could have been. Oh no, that was before. It looks like that was 10 minutes ago.
Let's do And I appreciate it. If I miss it, please help me. Okay, so example number 8. These last two examples are the hardest types of evaluation problems I can throw at you, especially example 9. 9 is like that pinnacle 5 out of 5 difficulty when you evaluate logarithms. And I will maximum throw one of these at you on the test. I'm not going to be doing more than that because they're difficult. All right, let's talk about example 8 first, the next medium step. I would consider example 8 kind of like a level 3.5 or 4 out of 5. So far, like I would say these are like level 3. This one was like a level 1. We're getting really, really hard here quick. So log base 25 of 5. Oh boy. This one, you can kind of do it on your fingers if you're tricky, but it's not very specific. These are problems that you now need to probably type in the chat. And you can type it to everyone. You can do a direct message, privately message me, whatever you prefer. If you like, not what if I'm wrong, I don't want people to know. You can private message me. It's okay. How do you do this? And again, you step 0, convert this to a what power function. 25 to what power gives you 5? Well, when I see this, it doesn't turn into a fraction, non-fraction, so it's going to be a positive answer. The negative answer makes it fraction or non-fraction. But how in the heck, like 25 to the power of 1 gives you 25. It has to be less than 1? How does that work? What's going on? And I see, yeah, there are people that are getting this in the chat. You're getting it correct. The answer is indeed 1/2. But why? Who can explain that? I need help. Charles, tell us, why is the answer 1/2?
So 5 to the to get to 25 from 5, it's the power of 2, and the opposite of that would be dividing by 2. Well, not dividing by 2, but square rooting, I guess. Yeah. So
Exactly.
would
Yeah. So
be
yeah,
how that
I think you have
works.
2 different methods. Let's write that out here for our notes. So in order to get from 25 to this 5, we're asking what value goes in here. That's the whole point of a logarithm, a what power function. What do I put in that little spot? Well, I know in order to get from 25 to 5, I have to square root it. And hey, I remember from a previous unit, a way to get rid of a radical symbol is to do 25 to the power of 1/2. And hey, this is literally what the what power function is asking for. What do I put right there? I put a 1/2 right there. Okay, so that's your like level 3.5 or 4 out of 5. We haven't done this hardest one yet. And this is truly a hard question, example 9. Before I do that, let's take baby steps. Fist of 5 on example 8. How are we feeling? How hard was that? I know I used some difficult rules already. All right. They're slightly lower, but still pretty strong. Our lowest, I would say our average is about like our average is probably about, yeah, a 4-ish. All right, let's try another one. This is the pinnacle, the level 5 out of 5. If you perfectly understand this, there's not much more I can teach you here. Log base 81 of 1/27. If I showed this to my calculus teacher, he would not have known what to do. He was an old person, didn't even know how to Google. So he literally would not know what to do. Maybe he would dig out his old college textbook and try to relearn logarithms. This is a really hard question, and you guys are going to be able to solve this. So when I see this problem, oh yeah, Charles?
Oh, I was just answering it.
Oh yeah, what'd you get?
I got 1/3. Oh, no,
Close.
sorry, -3.
Also really close, but not
Wait.
quite there. -3 is closer than
Oh, is
1/3.
it 1/3?
No, you're that's farther
Wait.
away now, colder. So the first thing that I notice about this problem is that both of these can be written as higher powers. Higher powers meaning some number to some power. And they both have the same base, which is helpful. Does anyone see the base? Something to some power is 27, something to some power is 81. Yeah, Wyatt?
27 is 3 cubed and 81 is 3 to the power of 4.
Exactly. So there's some trick using 3, which is why Charles is saying 1/3 or -3 and stuff like that. There is something with 3 is going to be in the answer. So let me show you how I think about this problem. Well, first I rewrite it as log base 3 to the power 4 of 1 over 3 to the power 3. I rewrite it using Wyatt's interpretation of higher powers. But the question is asking 3 to the power 4 to what power? What thing goes right there will give me 3 to the power of 3. And in fact, I can make this using some algebra. I can make this a variable instead of just saying a blank here. Let's make that a variable. 3 to the power 4, which was our base. This to what power? Let's go ahead and make that a variable. And we're finally hitting like the hard math of algebra. 3 to the power 4 to the power of x gives us 3 to the power of 3. And you can rewrite this and say that's 3 to the power of 4 times x. Because when you do a power to the power, that's times x. That's equal to 3 to the power of 3. Yeah, what?
How did you get 3 to the power of 3? It was just 1 over 3 to the power of 3. 3 to the power of negative 3?
Yes, I meant to write negative 3. Sorry. Thank you for catching
Okay.
that. That is
Thank you.
definitely extra credit.
I feel much better now.
I did not mean to do that. I mean, I meant to do that. Good job on catching my error that I meant to test your understanding of whatever. Okay, yeah. So it's supposed to be a negative 3 because I flipped this. I forgot to say that. I flip this. Whenever you flip it, it becomes a negative. So this to what power? To the power of x gives me a negative. And I rewrote that. When I have a power to a power, I can write the rule over here if you don't like me doing this. X to the power of a to the power of b is just x to the power of a times b. This is one of the rules of exponents that you should have learned from a previous unit. Don't remember which unit. But you also learned this in the previous unit or 2 units ago. Whenever you have the same base, the only way that these two things can be equal to each other is if the powers are equal to each other. These powers must be equal to each other in order for both of these sides to be equal. What that means, and why it has it now, what that means is 4x must be equal to negative 3. Essentially, we have boiled down the problem into like the first month of Algebra 1. Now solve. Divide both sides by 4. And you get x is equal to negative 3/4. So the answer to this what power function is unfortunately not something you can probably do in your heads right away. Maybe once you get really advanced. But the answer here is a crazy negative 3/4. And there's some work that's behind that. So I'm not expecting people to, everyone be giving me 4s and 5s on that one. That was a hard question. Let me talk about the definition of a logarithm and then we can be done with the notes to open it up for homework. This is the, oh yeah, Jade. Oh, is that a, oh, that was 4? Oh, wow, that's amazing. And that last question, you're really saying a 4? Okay, so I'll take it.
After you explained it.
Okay. Well, yeah, I don't know if the homework gets that hard, but let's see if something hard comes up like that again. Can you get it? Is that a question, Charles, or you gave me
Yeah,
a
it's a
5?
question.
Okay.
So when you do 27 to the power of 3, it's 81. So I was thinking, wouldn't it be just negative 3 since it's not a fraction?
27 to the power of 3 is a gigantic number. I don't know what that is. 27 to the
At
power of
least
3.
when I did it, it was some. Oh wait, I think I did division. Yeah, I did division, something like that. I did something else, I guess.
Okay.
But that's why I thought that. Sorry.
Got it. So this is usually the first rule that is in textbooks, and it is very confusing, but it's a good way to summarize what we've done in concise mathematical, maybe confusing language. This is what's known as the logarithmic form. Logarithmic form. Why is it called that? Look, there's a log. That's why it's called logarithmic form. Or if you don't like saying logarithmic, you can just say log form. I'm fine with that. Log form is perfectly acceptable. This is the same thing, mathematically speaking, as the exponential form of the same expression, exponential form, which looks like this. And I'm literally just going to invoke the what power function. What power does b need to raise to in order to get to y? So I'm thinking b to the blank power right here gives me y. And the answer is x. b needs to be raised to the x power. It already has the answer here. So b to the power of x gives you y. And this is what's in textbooks. They usually start off the unit by stating this rule. And when students look at that, they scratch their heads and say, do I just have to memorize that? And then they just memorize it and they have no understanding. Really, this is coming from the what power function. What power does b need to be raised to get y? Oh, the answer is x. B needs to be raised to the power of x to get y. So it is a form that kind of summarizes what we've done today. And we basically did this rule. I don't know if you noticed, but right here, when I set two things equal to each other, really what I was doing was I was changing my logarithmic form into exponential form. But that all comes from the what power function. If you understand that this is really a what power function, it makes your whole life with logarithms easier. That's my lesson. Let's give a fist of 5 for the entire thing. I know that you might not have the perfect understanding on example 9 if that came up again with new numbers, but in general, how well can you evaluate logarithms with various bases and sometimes including fractions? See a 5 from Charles, 4 from Wyatt, 4 from Jose, 5 from Jade, 3 from Jessica, 4 from Andres, 3 from Jenny. Okay. So I would say that's much better than the one that I had in high school. So you're already doing better than me. Good job. Let's attempt to do the homework. The first assignment is kind of like doing examples 1 through 5, nice and easy type of questions. And then examples 6 through 9 is the second homework assignment, the more advanced version. Let's see how well you guys can do. All right, good luck.